Section 7.1 continues on, giving you a bunch of other interesting kinds of functions. Here's one that I think is particularly interesting. It uses the idea of the power set we had before. Remember, a power set is going to be the set of all the subsets of a set. So if we look at the power set of the set A, B, and C, we're going to get this set here as our domain. So it's got the null set, which is a subset of every set. It's got the set containing A, set containing B, set containing C, the set with just A and B, the set with A and C, and the set with B and C. And finally, we have the entire set itself. What we're going to do is we're going to map that set into the non-negative integers. And the way we're going to do it is we're going to look at how many elements are in each one of these sets, sometimes called the cardinality of the set. Well, the null set has 0 elements in it, so it'll map to 0. The set with just A, the set with just B, the set with just C, they all have a single element in them, so they all map to 1. These 3 sets have 2 elements, so they map to 2. And finally, this set has 3 elements, so it maps to 3. It's just a little different kind of a mapping. Your text goes on and looks at a whole bunch of other different kinds of sets, such as functions defined on the Cartesian product. And those include exponential functions. They include logarithmic functions. They don't do it in your text, but they would also be the trigonometric functions. You've had entire classes about these. I'm not going to stress those here. Your text also does a little bit of discussion about coding and decoding functions. They also take a look at how hashing algorithms might work. Well, they'll actually do hashing later on. They'll do the hamming for the distance function here. These are things you'll probably see more fully in a computer science class. I'm not going to stress them right now. Something that is worth taking a minute to glance at is the idea of a Boolean function. At the beginning of this class, in the very first chapter, we looked at making truth tables where we could have inputs coming in like P, Q, and R, in which case when we had the 3 inputs coming in, we would have a truth table with 8 rows in it, and the output was going to always be a 0 or 1. It's only got one output for each one of the ordered triples coming in. So what we could do here is we can see this as really a function where it maps each one of the ordered triples as the input into a 0 or 1. It's a different way of looking at the Boolean relationship that you saw in the truth table and seeing it as a function. And indeed, when you do this in many computer classes, you will turn it into a computer function. At the very end of section 7.1, there's a discussion of an important term. The important term is well-defined, and this is something we are going to have to deal with, and it's going to come back to us. When we say something is a well-defined function, it means it is a logical function. If a function is not well-defined, well, that means it's not really truly a function. But it might look like a function, but when you test it, you discover that it's not. Here's an example of something that is not well-defined. I'm going to do a mapping from the rational numbers, the fractions, into the integers. So I'm going to propose that there's a function that goes from these fractions into the integers, and the way I'm going to do it is I'm going to take each fraction and I'm going to add the numerator and denominator to get the result in the codomain. So if my fraction is 2/3, I'm going to take 2 plus 3 and get 5. If my fraction is 1/3, I'm going to take 1 plus 3 and get 4. Well, so far we have a good mapping. How about if I take 4/6? Well, that's going to be 4 plus 6, so that'll map to 10. Looks like a good function until you get to this one. And this one does have a problem, because notice with these two, 2/3 is the same thing as 4/6. This one just isn't in lowest terms. But how can I have 2/3, which is equivalent to 4/6? 2/3 is the same thing as 4/6 here in the domain. If you try to map it as 2/3 to 5, but as 4/6 to 10, well, you see we have that one element going to two places, and this is not a function. When we say something is not well defined, it is saying that it is not a function.